The next ones, we are going to solve exponential expressions. And there are a couple different ways you could do this, but the first way they're going to do it is by trying to make a common base. Since I can write 64 as 2 to some power, they're going to do that instead of taking the log or the natural log of both sides, which eventually we'll end up having to do to solve these. But if you can rewrite it so they have a common base, that's usually easier to do. So this is still going to be 2 to the 5x minus 3. 2 to the what power is 64? Sixth power. So we would say 64 is 2 to the 6th raised to the 3 minus 9x. When we raise to a power, we multiply those exponents, right? So 6 times 3 is 18. 6 times negative 9x would be minus 54x, right? Now, since my bases are the same, my exponents would have to be equal, so I can basically just ignore that 2 is there. 5x minus 3 equals 18 minus 54x. So I would probably go ahead and add my 54x and add my 3. 59x equals 21. So x is going to equal 21 over 59. I don't think I can reduce that down, can I? Nope. So that's going to be my answer. So number 14, I can write 100 as a base 10 number. 100 is 10 to the second power. So 10 to the negative 6x would equal 10 squared to the 2 minus 2x. So our negative 6x is going to equal, and when I multiply that out, I would have 4 minus 4x, right? So if I add my 4x, negative 2x equals 4, and divide by my negative 2, that one comes out a little nicer. I get x equals negative 2. So number 15, I can't write 64 as 32 to some power, but I can change both my bases, right? 64 we already figured out was 2 to the 6th power, and 32 I can write as 2 to the 5th power, exactly. So now that they have a common base, I can just set the exponents equal to each other, so I would have what? Equals negative 5x minus 15. So solving that, we would add 15, so 21 equals negative 5x, and then divide. X equals negative 21/5 for our answer.